Now this graph tells a very interesting story. I don't really know if this scenario is still applicable for phones, but I suspect with certain phone plans this is exactly how it still works. Often when you pay for a cell phone, you'll pay a fixed cost. In this case, it looks like $30 each month just for having the phone, even if you don't talk at all. You pay $30 a month. Now, if you can pay no more than 30, like your bill will be 30 unless you exceed 400 minutes talk time. So after 400 minutes, they start charging you per minute for the amount of time you're on the phone. This graph tells a story. And if you were paying that bill, you would want to understand that story well. Okay, so the rate that they're asking us for is for the talk time over 400 minutes. So it's essentially just saying find the rate of change of this steep part of this ray that starts here and goes infinitely in this direction. But I can't help myself. We'll talk about the rate of change of this other part in a minute. But for right now, let's just find the rate of change of this line. And that's kind of tough because look, this point is perfect, right? I can see that that's 600x and 100y. But when I look for another point, there's nothing. Nothing's good. Nothing's perfect. This is as good as it gets. Because it looks to me like that is at the midpoint of this range from 20 to 40. So I'm going to feel confident that that's 30. And so when I find my change in y over change in x for the rate that I'm going to pay for my phone after 400 minutes, I'll start at this lower point and I'll move up for the delta y. I'm going up from $30 to $100. So that's an increase of positive $70 over this change in x, which is I'm going from 400 minutes to 600 minutes. So that's an increase of positive 200 minutes. 70 divided by 200, I'm going to factor out the 10/10ths by doing that. And then you're okay to do it on a calculator, but I'm just going to really quickly do 7 divided by 20. Long division, there's 0 20s and 7. I line up the decimal in my quotient. There's 3 20s and 70. I get a difference of 10/10ths. I bring down a 0 in the hundredths place. It was always there, it just wasn't showing. And there are exactly 5 20s and 100. So this comes out to 35 hundredths of a dollar per minute, also known as 35 cents per minute, because cents are hundredths. 35 cents or 35 hundredths of a dollar per minute. Let's see if we can find it. Oh, there it is. ET right there. Now, look, I'm trying not to make this overly long, but I just want to, there's an important point to be made here about the rate of change of talk time for less than 400 minutes. Let's pick 2 points here, delta y over delta x. If I go from this point to this point, the delta y is 0, because at this point I'm at $30 and at this point I'm at $30. So $0 per, the delta x is plus 400 minutes. 0 divided by 400 is 0. So $0 per minute is the rate of change for any amount of time up to 400 minutes. That's what that's telling you, is that not that you're paying $0, you're paying $30, but you're paying $30 no matter how many minutes you use the phone up to 400 minutes. So that the rate doesn't change. It remains constant at $30 per month. But it changes by $0 per minute. Like you can be on it for 100 minutes, 200 minutes, 300 minutes, all the way up to 400 minutes, and your monthly bill will not change. There's no rate of change until you hit the 400 minute mark.